All right. Well, I just spent several minutes recording a lecture that didn't happen, so guess we'll start over. Let's see. Here we go. All right, so what I'm going to do is go over the first part of Chapter 5, Part A. Then after that, probably Monday or Tuesday, hopefully Monday, I'll do Part B and then follow up with a third part of the lecture where I'll use some of the examples in the book and use Excel. All right, so what does time value of money mean? It means that you can earn, well, the amount, if you invest a certain amount today, you will earn interest on it, so it'll be larger sometime in the future because of the interest earned. So if I invest $100 today, annual yield of 6%, I'm going to have in the future, end of 1 year, $106. So I have more in the future than I do today because I earned interest on it. This time value of money concept is used a lot to value assets as well as liabilities, both financial and non-financial. One thing you have to look at, another concept that's used a lot is compound interest. So to understand compound interest, you have to understand simple interest. So, of course, interest itself is defined as the amount of money you earn on a certain amount invested over a certain period at a certain interest rate. And you could think of it as the amount of rent that's paid on an amount received or invested somewhere. Or you could look at it as if, let's say, you loan $100 to a friend and they're going to pay you back at the end of 1 year. Well, that $100, if you had it, well, by giving it to your friend, you're now sacrificing because you don't have the use of that money. And if you did, you could earn interest on it. So you could look at it as a privilege for sacrificing your use of the money. And so simple interest is just determining the initial investment times the annual interest rate times either the period of time or fraction of a period of time, and usually that's in either 1 year, or which would be 12 twelfths, or a fraction of a year. Let's say it's after 3 months, it would be the period of time would be 3/12. For compounding interest, you not only earn money on the initial investment, but you also earn money on the interest that's already been earned. So you're earning interest upon top of interest. So what is the simple interest earned each year on $1,000 if it pays 10% per year. Well, you're going to earn $100 calculated as such. What about with compound interest? Here, compounded at the end of 1 year. Well, sorry, at the end of 3 years. Because if you just do it for 1 year, your compounded annual interest is going to be the same as simple interest. So in order for compounding to work, you have to invest in more than one period. So here it's 3 years. So you're going to take, and you could do it the long way, simply figure out how much interest you earn at the end of each period. At the end of one, you earn $100, so you have $1,100. At the end of year 2, you're going to take and multiply 10% times 1,100 to come up with 110, and add that to the 1,100 to come up with 1,210. And then at the end of year 3, you're going to take 1,210 and multiply it times 10% to come up with 121, which is going to give you 1,331. Now understand also that if compounding occurs more often than 1 year, then your effective rate, or the actual rate of return, is going to be greater than the stated annual rate. And so, and for banks, I mean, some banks in savings accounts that you invest with them, they'll compound daily, but some other variations are semi-annually, so twice a year. In that case, you're going to take your interest rate, the annual rate, stated rate, and divide it by 2. So you're going to compound more often in that year, each year. If it's quarterly, you're going to divide the stated rate or annual rate, 12% divided by 4, because you've got 4 periods. Of course, if it's done monthly, you'd divide it by 12 periods, 12 months. I mean, literally, if you did it daily, you'd divide 12% into 365. So here, compounding happens twice a year. So you're going to take that 10% and divide it by 2. And again, the long way, you're earning 5% on $1,000 in that after 6 months. So you have $1,050 after 6 months, and then you're going to take that 5% and multiply it by 1050 and come up with 5,250. Add that to the 1050, you come up with 110250. And so to figure out the effective rate, the real rate, not the stated rate, you're going to subtract 110250 from the initial investment of 1,000. So that's going to be 10250, and then you're going to divide that into 1,000 to come up with an effective annual interest rate of 10.25%. Let me check something here. Make sure my recording is working. Okay, I think I'm going. I don't want to have to do this a third time. All right, so let's talk about future values and present values. So future value is what you'll have at the end of a certain period if you earn a certain amount of interest and invest a certain amount today, which is the present value. So here the present value is $1,000. The number of periods is 3 and the interest rate is 10%. Here it's compounded annually. And so the number you come up with is 1,331. Well, how did you find that out? Well, you could do it the old-fashioned way, just calculate every year. Or you could, if you wanted to, you could go to table 2 at the back of the book. It's like after the index, last 5 or 6 pages. Table 1, future value of 1. So you just simply you go across the top. You have your interest rates, and then on the left-hand side, top to bottom, you have your number of periods. So you go to 3 and follow it all the way across to 10%, and you come up with 1.33100. So that's what you see here. So 1,331 is, you multiply that times the 1,000 initial investment to get your future value. You can figure out the present value if you have the future value and you know your number of periods and your interest rate. And you would simply take the future value and divide it into 1 plus the interest rate to the power of however number of periods you're investing this in, or the compounding occurs. Now again, if it's compounded more than annually, you're going to put the interest rate. Let's say it's quarterly. You're going to put interest rate of, let's say it's 10%. It's going to be 0.025 or 2.5, depending on what software you use. Probably 0.025, right? If you use software, just if you're going to do it manually like this, 0.025, and then your number of periods is going to be, well, if it's 1 year, 4. If it's 3 years, it's going to be 12. So here, 1.10 times, or excuse me, plus 0.10, since it's annual compounding, to the power of 3 is 1.331 divided into the future value of 1331, or 1331 divided into 1.331 to come up with a present value of $1,000. Now again, you could do this by looking at table 2 at the back of the book. You would simply go to period 3 over to 10%, and you come up with the number 0.75135. So you would just simply take 1331 and multiply it by 0.75135, or 131, excuse me. So you could certainly do that. So the question here, and again, we're dealing with present value of a single amount. Most of what we're going to be dealing with are present values, either present value of a single amount or present value of an annuity, which we'll cover in Part B. And like bonds, they have both. Present value of a single amount, which is the principal amount of the bond, which face amount of $1,000, and then your annuity is your interest payments over the period of the bond. All right, so here's a question. given the present value and future value concepts, would you want $1,000 today or $1,000 in 3 years? And the obvious answer is you want $1,000 today because you could take and invest that and earn interest on it and have more than $1,000. Whereas $1,000 3 years from now, it's not going to be worth as much. Now, second question, if you were given a choice of getting $740 today versus $1,000 in 3 years, which would you take? And the answer is, well, it depends on what the going interest rate is. And so if the going interest rate were 10%, you would choose the $1,000 in 3 years because you could earn, that's worth more than what you would earn on $740 in 3 years at 10%. So that's that example there. But at 11%, you would choose the 740 because you'd actually earn more than $1,000 at the end of 3 years. So anyway, with present value and future value, you've got this interest component. To figure out future value, you add the interest component. To figure out present value, you subtract the interest component. Now, understand also that if you have four elements. You have present value, future value, interest rate, and number of periods. If you know three of those, you can figure out the fourth. So here we don't know the interest rate, but your friend wants you to let him borrow $500 today, and he'll pay you $605 in 2 years. So question is, what is the annual interest rate? Well, here what you're going to do is you're going to divide $500 into 605 and come up with 0.82645. And then you would go to your tables, table 2, and you're going, you know your number of periods. You know the amount, you know present and future amounts, and so you divided the present value into the future value to come up with 0.82645. You go to table 2, and if you notice in all this mess, under 10% at 2, so going across at period 2, you notice that under 10%, it's exactly 0.82645. So that's your interest rate. All right, what if you know the interest rate, the present value and future value? What's the number of periods? Well, again, you're going to divide 10,000 into 16,000. And you're going to come up with this number, 0.625. And then you're going to go to, again, table 2. And again, you're going to look under 10% since you know that number. And you're just going to go down 10%. And the closest number, it's not exactly perfect, but if you look at period 5, 0.62092. So it's somewhere between 4 and 5 years, but it's closer to 5 periods than 4 periods. All right, last but not least, preview of some of the applications. One thing we'll be dealing with are monetary assets and liabilities. Understand that monetary assets are money and receivables. Monetary liabilities are note receivables, or note payables. So valuing a note, how do you do that using present value? Again, that's the main one we're going to be using is present value. Well, let's put an example out here. One payment, the interest is in the contract. This company, Stridewell, is going to sell $50,000 of merchandise. They'll pay it in 1 year plus interest at 10%. So the question is, how do we value that? Well, normally it's just going to be the face value. What are we getting in 1 year? Well, we're getting $55,000. You could take the $55,000, the future value, and we know the number of periods and we know the interest rate, and we could just verify the present value using those three numbers. And again, if we go to present value table 2, at the end of 2 years, we get, 1 year, 0.90909. So you take 55,000 and multiply it by 90909, and you get, lo and behold, 50,000. So you just verified what you probably already knew. And that's usually the way it's going to be when you have a stated interest rate and a set amount and a set number of period. Now, a variation of this would be where, in this case, one payment, no interest is stated. Well, even though interest is not stated, it's still implied. So here we have the sale from Stridewell to Harmon. Terms of the sale require Harmon to sign a non-interest-bearing note of $60,500 with payment in 2 years. All right, so we have $60,500 paid in 2 years. That's our future value. The number of periods is 2. Well, how do we come up with an interest rate to find out the present value? Well, it's going to be the market rate, or what this would go for, this kind of loan would go for. In this case, it's 10%. Okay, now we have our third element. We can take the 60,500 and use our table or math or Excel. Let's use the table. 60,500 to at 10%, so 60,500 multiplied by 0.82645 is 50,000. Okay, so that's it for section A. Again, I'll do part B either Monday or Tuesday, and then I'll do another lecture on Excel, basic Excel.